Hello, AP Stats. We have here a review of probability, and I'm really hoping this will help you out a lot if you're struggling with probability, and even if you're not, it'll help show you how much you know of all the different types of probability we may have on the exam. So we're going to start out. Please follow along in your notes, and as we go, I want you to solve problems. Pause the video, solve the problems, and then I'll give you the answers to them. Any problems at the end that you have missed, I will have those worked out on your Sophia so that you can look at those if there were ones that you could not get the same answers that I had. Okay, so first of all, our first type of probability problems we did in Chapter 2, normal calculations. And these should be very easy to us now, our norm CDF and our inverse norm problems. Do remember that if you do not put in the mean and standard deviation, you can use z-scores, the low z-score and the high z-score, to get a percent that's in the shaded area. If you include the mean and standard deviation, that will also give you a percent x scores in that situation. Remember to use inverse norm if you want to find a z-score or an x score if you're given the percent. Like a percentile, make sure it is the percent below that score. So if you're looking for the top 10%, for instance, you do inverse norm of 0.9 to find the z-score, and 0.9 comma the mean and the standard deviation to get the x-score. So to recognize these problems, make sure you look for the words normal. You can't use it if it doesn't say normal distribution. Remember to use the z-score formula if you're trying to compare, like your chemistry grade to your stats grade, for instance. Remember that you can always change this formula, this z-score formula, around if you have to find a mean or you have to find an x score. And make sure you know the 68, 95, 99, 7 rule. And on all free responses, when you're using norm CDF, be sure to draw the curve and show the mean and the standard deviation, either written on the curve or in this normal notation. Also be sure you shade your curve. Next group was from Chapter 6. This was our, Chapter 5, Standard Probability Rules. And make sure you're aware of which ones are on the formula sheet and which ones aren't. So here on the formula sheet are OR addition rule. The probability A or B is the sum of A plus B minus their intersection, the AND. Remember, for OR we're going to add generally, and for an AND we're going to multiply generally. Now, the special cases here I have in yellow. No, if it's mutually exclusive, the probability of A and B is going to be 0, of course. So A or B would just end up being A plus B, because this term, of course, would become 0. No, if it is independent, and be sure you know the difference between independent and mutually exclusive, that your A and B would just be A times B, and we'll talk about why that is later. And so your OR formula just becomes A plus B minus A times B. If you understand those, then you don't have to memorize anything. You can just go to this formula on the formula sheet every time and just remember how to change it up for the different situations. The multiplication rule is really in the formula sheet as a conditional probability. The probability of A given B is the probability A and B divided by the conditions on the denominator. So of course, if you turn this around, you'll have A times B given A, so that's your general multiplication rule. But if it's independent, remember, for independent, probability of A is probability of A given B. And so that can be a test for your independence, and that's why that multiplication rule just becomes A times B. If two things are independent, you can just multiply the two, because it doesn't matter if A has already happened. It will not affect the probability of B. No, if A and B are mutually exclusive, they are dependent. Mutually exclusive things cannot be independent. Very important. So using those formulas and what you know about independent and dependent, try these two problems. Pause here, and then I'll give you the answers. Okay, the answer to number 5 is 0.6352, that's C. The answer to number 2 is B. Probability A or B ends up being 1. If you struggled with those, no, I will have those answers written out at the end. Okay, next part, make sure you know how to use a tree diagram. If you're using conditional probabilities, you know that this is a good time to use this. And here I've written it out on your sheet. Remember, if you multiply along the tree, you'll get your ands. If you add 2 ands, you'll have a total probability of D in this case. And that's often what they're asking for. But many times they're asking for the probability of A given B or B given A, the opposite conditional that you're given. Always on your tree, start out with a probability that is not conditional and build from there. So if you want to try this problem about heart disease, go all the way through it, see if you can get the answer. The answer to number 14 is 0.5439 is the probability of getting the disease having tested positive. Okay, part 3 here from chapter 6 is our random variables. So this is what we've been studying in our current 2 chapters. Recognize a random variable problem will usually be a 2x2 table with a list of values for your random variable, usually called X, and the probabilities underneath it. To find any probabilities, you just add, that's easy. To find the expected value, this formula is on your formula sheet. You do each term times the probability and add them all up. Very easy and very common. And also know that to find standard deviation of a probability distribution, each number minus the mean that you found here, the expected value, square it times the probability, plus the next one, and so forth. And if you're doing a free response, you can write it up on here with just the little dots if you want to. You don't have to write it all out. Another thing from chapter 6 is the rules for means and variances. Very important. Here I've put in 4 different situations. If you're multiplying a variable times a constant, if you're adding a variable to a constant, if you're adding 2 random variables, or if you're subtracting 2 random variables. And as we know, means usually do exactly what was done to the original variable, so that's not particularly hard. For standard deviation, remember you can only multiply by the absolute value of the constant, so make sure that stays positive. You'd never add or subtract to standard deviation. And if you are adding or subtracting random variables, you always add their variances. You have to bring it back to variance, and then you square it at the end to make it standard deviation. And you have to always add it even if you're subtracting. Notice these rules only apply if the 2 variables x and y are independent. Sometimes a multiple choice will come up and it'll have the answer, and then one of the choices will say not able to be solved, and that's because those variables x and y were not independent. So if you can conclude that, make sure you do not use the formula. Okay, so do these next few problems, number 1 and 2 and 6 and 7 and 8, using random variables and probability distributions. Pause. The answer to number 1 is 0.4 B. The answer to number 2 is 0.6 C. The answer to number 6 is X equals the value of the bill selected. The answer to number 7 is a probability distribution with the first rows having the X values, $1, $2, $5, $10, and $100. And the second row including their probability of X, which would be 1/2, 1/4, 3/20, 1/20, and 1/20. Of course, you could write those as decimals as well. Number 8, the expected value would be $7.25, which I want you to recognize. That doesn't makes this not a very good game to play, because you're only only expected to make $7.25, and it costs $20 to play. Okay, binomial and geometric random variables. This was chapter 6. Make sure you know the difference. You will look for words like 4 out of the 5, at least, at most, exactly. Know the 4 reasons that make something binomial and the 4 reasons that make something geometric. So you'll use binom PDF when it's exactly and binom CDF when it's a range. And there's the formulas written out. On a free response, be sure to tell what the distribution is, binomial or geometric, and define n, define p, or use that notation b parentheses n comma p. That'll work to know that it's binomial. You've got to tell that it's binomial though. You should be extremely comfortable with the binomial formula, which is on your formula sheet, but how to use it. N choose k, probability of success, and you want however many successes, k, and the probability of failure, and all the rest of the things needs to be failures. And the binomial coefficient, N choose k, is right here. This is not on your formula sheet, so be aware of what that means. And it's done as N choose R on the calculator, and that's rare that you have to just calculate that. Mean and standard deviation of a binomial is on your formula sheet. Sometimes it's hard to recognize on a problem because it's not going to say it is binomial. So if they ask you for mean or expected value and standard deviation, and it's not one of your traditional methods of finding a mean, then you might think to yourself, well, is it binomial? For geometric, we're looking for the probability until a success. So we want only one success here every time, probability of success, times the probability of failure to the, I put lots. In other words, however many failures you need. So what's the probability that your first success is on the 6th time would be the probability of success times Q to the 5th. Mean and standard deviation are not on the formula sheet. Really, standard deviation is not used on the AP exam, but do know the mean is 1 over P for geometric, and that should be pretty intuitive if you think about what that should mean. Try these binomial geometric problems, number 1, 2, and 3. Pause. The answer to number 1 is A. The answer to number 2 is B. The answer to number 3 is D. Go ahead and try number 5. This one's tricky. See if you can get it. Pause. The answer to number 5 is D, 0.8171. Whenever you want a geometric to be greater than something, you just need to make sure that it fails, probability of failure, that many times. So to find this, you do 0.98, that's the probability of it not being defective, to the 10th. Okay, last thing is sampling distributions. This is what we're doing now. First of all, for means, know when, that should say, to use the central limit theorem. The central limit theorem is for means, not for proportions. It'll look just like a norm CDF problem, but you'll be given a SRS or an N, a value for N, and it'll be about sample means. So it'll be what's the probability that the average SAT score is greater than such and such in a sample size of 10, for instance. Remember, use norm CDF, but the big difference is your standard deviation. You're going to be using sigma over root n. The central limit theorem says as n increases, and we're going to use greater than 30 as our rule of thumb, the shape will be approximately normal with a mean of mu and a standard deviation over sigma over root n. For proportions, if n times p and n times q are greater than 10, that's your check for approximately normal. Then the mean will be p and the standard deviation will be square root of pq over n. This is all on your formula sheet. You'll be looking for a simple random sample where you're given a population proportion and again an n value. These problems are pretty rare with the proportions. We'll use them a lot for inference, but they're rare by themselves. Central limit theorem and mean problems are much more common. So try number 6 and down here number 1 and 3. These are all mean sample mean problems. Pause. Number 6, the answer is C. Number 1, the answer is 0.2674. And number 3, the answer is 0.4549. Great work. Thank you. Write down any problems you have. If you need to check more answers, they will be after the video. Good job.